Sudden land subsidence. Sounds scary, doesn't it? I'm referring to an article that made the rounds a few weeks ago about the concept that if we were to experience a major Cascadia earthquake, the coastal lands along the Washington coastline, Oregon coastline, Northern California coastline could drop 6 feet or more. And so now I want to talk about exactly why that is, geologically speaking, and I'll try and put a link to that story in the comment section if you haven't read it. Let's go back to Geology 101. The Earth's surface, the crust, broken up into more than a dozen plates or tectonic plates. They kind of fit together like a jigsaw puzzle. They move with respect to each other. Every once in a while, as they slide, it sends out a vibration. That vibration is an earthquake. Now, one such boundary is the Cascadia subduction zone. This is where the Juan de Fuca plate, which is made up of oceanic crust, meets up with the North American plate, which is made up of continental crust. Now, oceanic crust is more dense, basaltic, so when these two converge, the oceanic crust tends to subside below, and so that's what we have going on here at this converging boundary. Now, every once in a while, as these plates converge, you get motion along their contact zone. That slip sends out the vibration. That's an earthquake. This has happened on occurrence every 200 years to about 1,000 years. Last time it happened was about 325 years ago. In other words, the period can change, and we don't know when the next one will be, but it will happen again. But what I want to point out is in between these earthquakes, in between motion along this zone, it actually is stuck, but you still have movement. And we know that because GPS sensors actually track the movement on an annual basis. So what happens when you have these plates converging, but there's no motion, there's no movement along the plane zone here? And the answer is distortion, deformation. So you continue to have immense forces that cause the North American plate, the surface, the crust here, to bow upward. We call that uplift, and over millions of years that can generate mountains, but over the course of a few hundred years we can still have substantial rise that can take 1 point and rise above sea level where it was below sea level before, hence the 6-foot rise or drop that we're talking about in this case. So while we're waiting for that slip, we just get this uplift that continues. Now eventually we'll get to the point where we do get the earthquake, you get slip, and then the surface of the North American crust snaps back partially to its original shape. And that's where you get this little zone here right near the coastline that could actually drop below sea level. So that's what we're talking about when we have these areas that are at an increased risk of being in a flood zone after the earthquake would occur. And then it would take hundreds of years again for this process to continue itself and repeat and build that area back up above sea level. So a little Geology 101 for you. Another thing to note, that an earthquake of this magnitude would likely also send out a tsunami that would temporarily increase those water levels even more. Something we watch for, something the tsunami warning centers would send warnings out for. But just a reminder, if you do live in a tsunami zone and you do experience a large earthquake, the main thing is once you're safe from that main earthquake, you should head to higher ground and then look at the warnings that come out to see if you're at risk of a tsunami. All right, have a safe weekend. We will continue to watch things here on KOMO News.